Welcome to Kubernetes Philly November. I'd like to thank Andy Grabner for joining us this evening. Let's see. Come on, PowerPoint. Now we'll respond to clicks. I've broken it. There we go. So tonight we'll talk some quick group business. Andy will lead us through a great presentation on SRE-inspired DevOps. I'm actually really looking forward to this because when I saw this topic come up on the submissions, I'm like, ooh, that'll be fun. And then any closing business. So as far as our opening business goes, as usual, if you'd like help with speaking, streaming, or want to help out with Kube Philly, hit up the links. Let me freeze those for a minute so you can see them, or not. PowerPoint just misbehaving. I'm just going to stop the share because it doesn't want to behave, but that's fine. So if you want to help out, you know where to find me. I'm on Meetup, like everybody else who's in the group. So if you're interested in any of those things, by all means, hit me up. And as for other normal business, anybody looking for a job in the CNCF space or looking to hire in the CNCF space?
Yeah, actually, I could use another senior platform engineer at a company called Page. Website is page.ai. We are a startup that is focusing on using AI to help with the treatment of cancer and diagnosis of cancer. So Page AI, or you hit me up in chat, and I'll be happy to get you some information.
Awesome. Thanks, Will. Anyone else? All right. So as far as tonight goes, I'm going to give Andy the floor. He'll do his presentation. Feel free to use the chat for live questions, or is there a raise hand feature? I even really looked at that. It's kind of hard to see. There's a raise hand feature. So, Andy, if you feel like calling people out to ask questions live, whatever you're comfortable with is fine by me. Yeah. Jerome put first Kube Philly meetup was on 10/16/2016, 4 years ago. That's crazy. Thanks for looking that up, Jerome. Appreciate that. But that's hard to believe it's been that long, but I guess it has. So awesome. So with that, Andy, the floor is yours.
Thank you so much. Well, good evening from Austria. It is past midnight here, but I'll try to get all of my energy together to really, not put up a good show, but actually making sure that I can tell you a couple of things that I've been working on over the last couple of years in the CNCF space. I'm representing an open source project. Actually, let me share my screen so you can actually get all the details. So I always say a day I work at Dynatrace as a so-called DevOps activist, and at night, as tonight, I am a DevRel for Captain. So I really try to take our open source project. It's a CNCF sandbox project, and really make sure that we bring it out to the community. We get feedback, because really what we want to do is with this project to provide a new way for delivery and also operations. And you will see that we have an event-driven approach, which I think some people have already tried. It's nothing I would say completely new, but I think there's only a few tools out there, or a few frameworks that I think providing a good alternative to the traditional way we deliver software. If you have any questions, you'll have all the details here. If you want to follow up later, or people that may watch this recording, because I know some people might not be able to make it tonight. It would be great if you give us feedback on Captain. You can see how you can follow us on Twitter, how you can obviously get all the details on GitHub, and we also have a Slack channel. So slack.captain.sh is the best way to get in contact with the core team. Also, as was mentioned, feel free to ask questions. I have 2 monitors here, and I'll try to monitor if questions come in. I rather have it also. You can feel free to interrupt me, because then it makes it a little more interactive instead of me talking for, I don't know, 30 to 40 minutes. Good. Then let's dive into Captain and what I want to show you today. Actually, I want to start with a quick demo before I go into slides, because what I have here, and hopefully you can all see my slides correctly, right? Can you see my browser?
Yes.
Yep.
All good. Perfect. So Captain is a container-based event-driven solution. I currently run it on EKS. We also use different tutorials out there to run Kapton. So if you go to tutorials.kapton.sh, which is typically the place I point people to when they want to get started, there's different tutorials on running and installing Kapton on the different cloud platforms. K3s, we have a small installation that gets it there. We also have one on micro Kubernetes. We have tutorials, as you can see here, integrating Kapton with Argo, with Jenkins, and others, and also for different use cases. So in case you are interested in it, check out the tutorials. Now, what I have today, I have Kapton installed on my EKS. I can show you what I have here. KK is just kubectl in the Kapton namespace, because by default Kapton installs in the Kapton namespace on Kubernetes. And as you can see here, this is kind of what the default installation looks like. It's an event-driven system, and it comes with a couple of, we call them Kapton services. So Kapton is event-driven, and every service that wants to participate in the event-driven workflow basically subscribes to the event stream. And there's a couple of services that Kapton comes with out of the box. Obviously, I will go into the architecture a little more in detail later, but this is kind of what is in my Kapton namespace. For instance, I will do later on some deployment using Helm. So I have a Helm service. I'm doing some testing using JMeter. I have a JMeter service. I have a notification service to send notifications to Slack. I have a remediation service for auto remediation. From a monitoring perspective, I'm using Dynatrace. We also have a Prometheus integration out of the box. So you basically just add the tools to your tool belt, subscribing to the event so that Kapton can do its thing. The other thing that I have done in my Kapton installation, Kapton is organized in projects, and every project allows you to specify different workflows. And for delivery, you need to give Kapton a description of a delivery workflow. And what you see here is what we call the shipyard file. So in the shipyard, I basically specify what my delivery pipeline should look like. I have a dev stage, I have staging, and I have production. And in what the additional metadata is, it's just what should happen in the individual stage. So as Kapton is later on orchestrating that process, it knows when it receives a new artifact, it starts with dev, where it sends out an event to whatever tool you have installed that can handle a deployment event to say, please do a direct deployment. In production, as you can see, I have a blue-green deployment strategy specified. Test strategy indicates or tells the testing tools that you have hooked into Kapton what type of tests should be executed in that stage. So once it's time for testing, Kapton will send an event with additional metadata like, hey, I need a functional test in the dev stage, I need a performance peak test in staging, and I also just a regular performance test in prod, and so on and so forth. It's also an approval strategy. So you can always specify as Kapton is moving an artifact along in the process. It is also doing evaluations of SLOs, so service level objectives, by pulling in metrics from your monitoring tools. And then it comes up with a scoring where it basically tells you how you're doing. And then it is a score between 0 and 100. And you can also say what is your passing and what is your warning range. And then depending on that, you can also specify how the approval from one stage to the next should be. If it should be automated, if you're good, if it should be manual. So you can control this. So this is just my initial definition. So what I have here, if I switch back to my browser, the UI of Kapton, we call it the bridge. So why do we call it the bridge? Well, first of all, Kapton, and I guess you maybe have already made the connection. We're in the Kubernetes space, so everything is Nordic terms. So Kapton is the German, the way we spell it, it's the German phonetic of a captain. I'm from Austria. Most of the team is from Austria, and Austria, our native language is German. So that's why it's the German phonetic of Kapton. Kapton allows you to deliver containers safely into the target harbor, right? Kind of allows you to ship your software. As I said, Kapton is organized in projects. In my installation here, I have a couple of projects created for different use cases. I have one for quality gates. I have one for performance as a self-service. I have one that I want to show you now. That's the Kapton 07 project. And here, if I click on the environment overview, I kind of see from a delivery perspective what my workflow looks like. And remember, that's the dev, staging, and prod. and I can click on dev. I immediately see what is currently deployed. I have a link to the actual application that is deployed. Not that sexy, but I'm also not getting paid for building beautiful applications, but that's one of the apps that I kind of copy pasted and then modified slightly so it does its job well. But as you can see here, currently Captain has deployed. My build number 3 is in dev. If I go to staging and open up the staging link, this is my build number 3 in staging. And then I have build number 3 most likely also in prod if everything is good. My whole system is also, so obviously Captain runs on Kubernetes, and when I show you later on everything gets deployed on Kubernetes. I have, because I told you a day, I work at Dynatrace, so we have an observability and monitoring platform. So I have chosen to use Dynatrace for monitoring. So in my case, Dynatrace is monitoring my environment. It's not that exciting, as you can see here. It's a single node Kubernetes cluster. I've installed Dynatrace, so Dynatrace now is lighting up the sky, and it gives me all the metrics that I later can use for my SLO validation. But whether you use Dynatrace, another APM vendor, or Prometheus, you can integrate Captain with it. But because at day I'm a Dynatracer, I chose obviously the tool that I'm familiar with. So I have these 3 stages. I showed you that I have deployed build number 3 in prod, in staging, and in dev. And now what I want to show you and kick it off, because it will take a couple of minutes for the whole pipeline to run through. I want to show you how easy it is now for anyone really to kick off a new build, or actually to tell Captain, please orchestrate the workflow for delivery. And this is the comment. So what I'm using here is the Captain CLI, Captain, send event new artifact. So Captain is an event-driven system. So what I need to do is I need to send Captain an event that then starts triggering a workflow. And depending on what type of event I send, it actually tells Captain where should the process start and how long should it go. So a new artifact event will actually trigger a complete end-to-end delivery workflow. And as I showed you earlier, Captain is organized in projects. Like in my case, it's the Captain 07 project. I can onboard one or multiple services. So the idea is obviously if you have a multi-service microservice app, you have a project where all your services kind of belong into this project, and then you have individual services. And now the only thing I have to do is for a new artifact, I basically specify, okay, what is this new artifact? And I'm now deploying version number 4 of this container. So this will now send an event to Captain and basically say, hey, I got a new artifact. You know the process, right? You have the process definition here that I initially created when I created the project, and all the individual tools that will now interact in the delivery, event-driven delivery workflow will then just pick up the right events and then will act upon it. And the reason why I started this now is, as I said, this will take a couple of minutes. What I want to show you, or I want to at least wait for, is for the delivery of build number 4 in dev. So right now it's still 3. I can also click over to the services view. So on the services view, I can see I have only onboarded in this project 1 service, but if you would have multiple microservices, every microservice would show up here. And what you can see in the first list is basically every time I send an event to Captain that is triggering a new workflow, we call it the root event for a new workflow, then I will see that root event. And you can see here, I've been playing around a lot over the last couple of days with always alternating between build 3 and build 4. This is kind of my demo that I always play, because build 3 is most often good, but build 4 has a problem in production and will then actually automatically be rolled back by Captain as well. So build 4 is currently being kicked off, which means on the right side, when I click on this kind of, right, if I click on a different entry point here, then on the right side, you see all the events that Captain is internally sending, and then you also get information about which tool was involved for doing a particular job, and you can see kind of the final result. We also get down all the way into the weeds of the actual events that are being sent back and forth. Captain is event-driven, and we're basing this on cloud-native events, which is also a CNCF standard. So all these events that are sent back and forth are also visible and accessible here in the bridge. And as I said, what I would love to do is I would love to wait until my build number 4 is now in that stage where it was deployed. So deployment finished, Helm service. I could click here, or I go to this page here. Remember, build number 3 was in prod earlier. And if I refresh now, not prod, dev, where's dev? Here we go, dev. Then build number 4 is now in dev. Okay, this was just done automatically behind the scenes. Now, this was a quick just intro that you get familiar a little bit with, the Keptn UI, some of the terminology, the project services, and so on. This file here, the definition of a delivery workflow, we call it a shipyard file, right? We really try to keep keep this nautic terminology. There's a shipyard, the tools we call a uniform, and so on. Before I go into slides, does this kind of make sense? Any questions so far? Anything? No? All right, then let me give you a little more background and details. So really what Keptn is, and it really depends on who you are, what Keptn can be for you. So you might be a dev, you might be an ops, you might be an SRE, and what Keptn really does is that it allows you to pick a use case that you want to automate. It can be progressive delivery, what you've just seen, multi-stage delivery with different delivery options along the way, meaning we support, we integrate with different tools, whether it's Helm, whether it's Argo, whether it's Spinnaker, whether it's Jenkins, for doing, direct deployments, blue-greens, canaries, you call it, but Keptn orchestrates the whole process. You can also use Keptn just in case you want to automate SLO-based quality gates. That means if you have an existing delivery pipeline, let's say you're using Jenkins right now and you already deploy, and maybe you run already some tests, then you can say, Keptn, I want you to evaluate the quality of this particular deployment that I just made, because Keptn, as one of the capabilities, can reach out to your monitoring tool. Even not only monitoring tool, it can reach out to all sorts of different data sources, pull in data, and then validates and comes up with a score. The third one, SRE automation. This is all about if you have, if your developers have a new build deployed, then Keptn can orchestrate the execution of tests against that build. It can also combine tests. With tests, we typically here mean load and performance tests. So we have integrations with load and performance testing tools where it can kick it off. We also have integrations with chaos engineering tools like Litmus and Gremlin. So the SRE automation use case is about you have an application that is deployed, and Keptn can then orchestrate the execution of tests and maybe also enforce chaos. And in the end, gives you reports by pulling again metrics from your underlying monitoring tools to say, how is the system behaving under load and under chaos? And the last use case is auto remediation. This is for the operations side. So if you have if something runs in production and then let's say your Prometheus is giving you alerts on outages, on slowness, on something that, let's say, Kubernetes itself cannot handle itself by just restarting pods, or maybe the autoscaler cannot do it, then you can use Keptn to facilitate or orchestrate a process that executes different actions to bring the system back to a healthy state. This could be calling external tools to do something like, restarting processes, cleaning disks, whatever. You can call Ansible scripts. You can call your alerting and notification tools to create tickets. So Keptn does this as well. So you pick your use case, and these are the 4 primary use cases that Keptn can orchestrate the process of. Then for every use case, you bring your configuration. Right? Every use case obviously needs some type of configuration. You saw the shipyard file earlier that I showed you in the demo for the progressive delivery. For quality gates, we'll dig into this a little later. You can provide SLIs and SLOs. So what metrics against which objectives for quality gates. For SRE work automation, it would be the workload definition. What type of workload do you want to simulate? And for auto remediation, it's going to be your runbooks. And Keptn for this has open specs where you can then declare and define what should happen in this use case. Next thing is you connect your tools. So Keptn doesn't rip and replace your existing tools. Keptn is connecting to your tools and is orchestrating these processes by them allowing them to participate in these processes, in these workflows. So really what in the end Captain does, once you pick the use case, you bring your configuration and you connect your tools, it then automates the configuration of your tools and also provides self-service for these use cases to whoever you are, the DevOps or SRE. And we provide both, a UI, and we've seen some of it, but there's a little bit more, especially the heat map that you see here. This is part of our SLO validation. This is part of Captain. You have a UI. You also have an API, so you can integrate Captain. You not only can have Captain call your tools to do individual things like delivery, testing, and so on, but you can also, from your external tools, call Captain to trigger a workflow through an API. Yeah, and all of this works and happens through an event-driven process orchestration that is based on declaration, right? Everything is declared, declarative way, your processes, all the configuration files, everything Captain does, all the resources, all the files that the individual tools need, they're all stored and maintained in a Git repo that Captain keeps internally, but you can also specify an upstream to your own Git. Everything is centered around SLOs, meaning in every process, in all of these 4 use cases and all these in these 4 processes, SLOs, service level objectives, play a key role. For delivery, for testing, for auto remediation, SLOs are always validated fully automatically to make sure your system is at a healthy state. And Captain is open source, and the communication protocols are completely open and standards. All right. So let me pause again and let's see and ask a question to the group. Any other questions? Anything that is unclear or does make sense?
So I see the ellipsis by the connect your tools. What are the tools can you connect to Captain?
So the tools, the way you connect these tools, we do this through so-called Captain services. So you need to write a little proxy, I would say, that is subscribing to a Captain event. And then what we have, these tools on the bottom here, these are all tools we already have out-of-the-box integrations with, or that somebody has already contributed. So let me show you this. We have on the Captain sandbox, that's one of our repos. This is where you find all sorts of services that people have already developed. There's also a template. You can write a Captain service and a tool integrator pretty much in any language, but we provide a template for Go where you write a container that is then providing an HTTP endpoint that will be called whenever a certain event comes in that you want your service to handle. That's really what it is, right? And the template, I think, is really, we tried to make it very easy. So there's description on how you obviously build it and how you deploy it and how you test and develop it. But in essentially, what you need to do is you see here, these are the different types of events that Captain sends internally. Configuration change, deployment, tests, start evaluation, done, and so on. There's a couple more, and here you basically just add in your handle code. Like, hey, if you are providing, let's say, a tool that wants to handle a configuration change event, which is what I did earlier when I said I have a new artifact, I'm basically triggering a workflow that starts with a configuration change. So you could handle this, and then in the incoming event, you get the cloud event and you get all the data. Right? Does this make sense?
Yes, definitely.
Yeah. Cool. And yes, so we have, but that in general, good question. So we have a sandbox. This is where all the new projects, start their life, let's say it that way. And then we follow the CNCF model. Then we have a Captain contrib, right? These are kind of some of the core services we have that we know that have already a good adoption. Dynatrace is in here, Prometheus is in here, notification service is in here, and then we have Captain Core, which is just the Captain project. And here you have the Captain Core, all the specs, enhancement proposals, community, website. This is in here. Okay. And if you ever want to get started, the best way to get started is in the sandbox. Also, there's a little contributing repository that explains exactly, how you can get started. with contributing your own extension. Cool. All right. Now let me dive a little deeper. Also, first of all, in why we built Captain, because you may think, okay, why there's so many tools out there already? Why yet another new tool for continuous delivery and automated operations? Well, the reason why we built it, I think we've just been. It was great to see the State of DevOps report coming out. I'm not sure if who of you is following what's happening in the DevOps space, but the State of DevOps report comes out every year from Puppet Labs, and Dora and some other folks are contributing. And they just announced 2 weeks ago that based on the latest survey, 63% of organizations right now are building their next internal platform for delivery that focuses heavily on self-service capabilities to their engineers to deploy, to get infrastructure as a service, deployment as a service, monitoring as a service, and all these things. But they also highlight a couple of things that hold people back or that are impacting, let's say, their speed of adoption. And these are some of the things that Captain addresses. So we see a lot of organizations struggle with maintaining traditional pipelines for their new cloud native delivery, for their new cloud native architectures. We see a lot of people are spending, in general, time on manual tasks along delivery. And we also see a lot of people spending a lot of time in manual remediation. And these are three of the things we're addressing with Captain. If you want to, again, I can really highly encourage you to read the State of DevOps report. Because there's a lot of great information in there in case you've never come across it. Now, what I would like to, I want to quickly go into each of these three problems that we address. And this also then allows me, especially with the first one, how the architecture of Captain really looks like, even though you already got, I think, a little idea. But really kind of, I want to explain it to you based on the problem we want to solve. So I mentioned already, a lot of engineering time is wasted in maintaining monolithic pipelines. Now, this is a bold number, so let me explain to you what this really means. This is a Jenkins pipeline that we use internally, and while Jenkins is a great tool, I'm not bashing on Jenkins. We've used it for many, many years to deliver our traditional applications, and the challenge with Jenkins that I see is it is mixed information about the process, the target platform, the environments, and the tooling. So if you've ever looked at these, let's say, traditional generation 1 delivery tools, everything is kind of hard-coded, with hard dependencies put into one file, which means there's no clear separation of concerns between process, the tooling, and kind of the like how developers get feedback. It's all kind of cobbled together. So that's one challenge, I think, or one problem with these traditional pipelines. The second thing is we also at Dynatrace internally, when we moved from our monolithic Java-based applications that we used to write to the container-based world, of course, we use Jenkins for delivery because that's the tool we knew. And it does a good job still, right? But what we did is we started with the first pipeline, as you can see here, very simplified, obviously. First pipeline for the first service, then you onboarded more services. Every service maybe had the unique needs or requirements to do a certain step here, use another tool here. So copy, paste, modify it slightly, and then I think you get the idea. The more teams you onboard, the more permutations of the initial pipeline you get. Some organizations you may write, your Jenkins pipeline that manages other Jenkins pipelines by creating Jenkins pipelines on the fly. I mean, there's a lot of options how you can use Jenkins, and again, it's a great tool. But still, in the end, if something breaks, it's really hard to figure out why it breaks. And this is why I wanted to make this bold statement of 95% of engineering productivity time is wasted in maintaining pipelines and fixing them. So how can we fix this? We believe we can fix this by applying an event-driven approach to delivery, just as we are applying event-driven architecture to our software that we are writing these days, because we used to break up the monoliths into smaller pieces and connected it through events. So why don't we do the same thing with delivery? So to give you a picture, again, on the left side could be your current delivery process modeled in whatever tool you have, build, prepare, deploy, and then you have your hard-coded dependencies depending on the tool with that you're using for delivery with individual point tools. Now, what we are saying, let's break these dependencies and let's rip these two things apart. Let's have one entity that's controlling the process on the left, and let's have all the capabilities we need for delivery and also operational tasks on the right, and then connect them through eventing, just as we do with breaking the monoliths and then having a lot of different services that provide basically capabilities for a bigger cause for, let's say, business functions or business processes. And one of the examples would be, right, if on the left side you have somebody that executes or orchestrates the process, maybe at the stage of, hey, I need to deploy something, then the process orchestrator can say, hey, I need to deploy container number 1 into dev with a blue-green deployment strategy. Sends out the event, and then you can have one or multiple tools or, let's say, capabilities that can say, hey, yes, I can do this, let me do it, does the job, and then sends back a finished event when it's done. And then on the left side, the process can go on. So really, there's no rocket science, that we didn't come up with a completely grand new idea, but we're trying to apply this event-driven model into delivery. Okay, so figuring out what is the process and what is the tooling. And this now goes into the Kapton architecture. So Kapton itself is a container-based solution. That means, or it's a service-based architecture, obviously. So you install it on any type of Kubernetes flavor. At the core, you get a control plane that manages the processes, it orchestrates different processes, and then we're using eventing. Here we're using Nets as a library that is also open source. If you've installed Kapton, then, and if you want to use it, you've already seen the shipyard file earlier, but the way to use Kapton is you have to define which process do you want Kapton to orchestrate for you. And there's two major processes. The ones are targeted towards continuous delivery. This is where you can specify a so-called shipyard file, and you can do things like multi-stage, dev staging prod, like what I showed you earlier. But you can also specify a shipyard file, let's say just for one stage or only for a particular part of the process within a stage. So for instance, you could create a project that is only targeting I want Kapton to run a test and do a quality gate evaluation against SLIs and SLOs, or you can even go down to the smallest piece, which is just SLOs. On the top right, remediation. This is the second major use case and processes that Kapton can orchestrate. This is around remediating problems in production. So for instance, if a high failure rate problem is detected by my monitoring tool, then Kapton can first trigger a scale up and then a rollback. In the middle, Kapton is always validating. So to finish this, you are specifying a process. Then another type of group within your organization who is managing your tooling, they basically specify the execution plan. So which tools should be used as Kapton is orchestrating these workflows. And we call this the uniform. So the uniform of the Kapton basically says which tools should register to which events and should then kind of do their work and provide the capabilities as Kapton is orchestrating the workflow. And then in the end, the beneficiary for the continuous delivery use case would be the developer. Like I did earlier, here's a new artifact. And then if I give it to Kapton, Kapton says, I know my definition of my delivery workflow in my shipyard file, and then it starts sending the right events. It basically keeps track of state, and then it basically pushes the process along using events and therefore connecting tools. Now, the cool thing with this is you can at any time change the process definition without having to think about which tool you actually have underneath the hood. You can add a new stage, remove a stage, change the delivery model in a stage, but you can also, on the other side, easily switch tools. You can say, I'm now replacing JMeter as a testing tool with Neotis, but you don't need to think about where is this tool actually used right now. You don't need to touch any of the hard-coded integrations with the existing pipelines because everything is decoupled. Does it make sense?
Yes. Now, I'm not familiar with the Cloud Events framework. I was just browsing over it for a minute, but can Kapton respond to custom events or only to events that are considered, the kept and supported events?
Very good question. So as of today, we are the current release is kept in 0.7.3. And right now we have our set of events that I think if you look at our spec, you will see a handful, like 10 or so. With 0.8, which the plan is to go a preview in December, which for me, it is already December, actually, December 1st here, my time zone. No, but later in December, we'll come up with 0.8, and you can then define in your shipyard file your custom events as well. So you can really then, you're very flexible with what type of events you want Captain to then orchestrate, and then you can also react to any type of event.
Very cool.
Good. Any other questions to this here, to the architecture? Go once, go twice, go on. Okay, good. So this is then typically where I come in with the demo, and I think we saw it slightly already, but let me go back to my, remember build number 4? So build number 4 that I kicked off earlier, as you can see here, if I start on the right side, when I kicked it off at 0.52, it first did the deployment. We checked, we saw this earlier. Then tests were executed, and then SLIs were retrieved. That means then Captain is actually reaching out to the monitoring tool or whatever you specify to retrieve SLIs and SLOs. Now in my case, you can see here I didn't really specify any SLIs and SLOs. It is just going through the quality gate based on the result of my test. So JMeter is executed, and if JMeter, the integration, returns back result pass, and I don't have any additional SLIs, then it just passes. So that means it goes into the next stage, which is staging, which is great. I have automated approval turned on. That is why I see the approval request. So normally if you say manual approval, then somebody would either get a notification or in the UI you can then approve. But I specified automated approval into staging, which means the first thing that happens is configuration change event, meaning new version number 4 needs to be applied to production, to staging. The first thing that actually internally happens, it will update, in my case, my Helm charts in Git. And once these Helm charts are updated, then my Helm service also kicks in to apply these Helm charts. That means what I should be able to do now, I can do it here, or I can go back to this here. Remember that build number 3 was in staging. If I refresh, build number 4 is in staging now. Awesome. Right? If I click here, same thing. Right? So I get some links here that make it easy. Then tests get executed. In this case, in staging, I have tests that run a little longer. They run about 4 minutes, as you can see here. Between when a deployment finishes, tests automatically kick in, and then JMeter has reported tests started at 23:58 and they finished at 2 after midnight. It's great. And so on. And then here's, I think, the interesting part. Let me zoom out a little bit here, because here I have a little more quality gate details. So in staging, I've actually specified that I want Captain to reach out to my underlying monitoring tools and pull in a list of important SLIs metrics and then compare them against SLOs. And then what Captain does, it looks at every single SLI, rates it or grades it, and then also comes up with a total score. And in this case, my total score for this build in staging was 88. Let me zoom in again. Yeah, 88. And 88 is in my warning range, which is why if I continue, I now have this approval request, and it says, hey, Andy, currently in production, you have version 3 deployed. Version 4 would be ready to go into production, but because you specified that artifacts that are in warning should not automatically be promoted, you can now promote it here, or you can reject it. And I can either do it here in the UI. I should be able to go over here. Remember my dev, staging, and prod. Now in prod, I also see there's build number 3 is deployed, but there's a new deployment available, which is version number 4. I got 88 points. I can also hover with the mouse over to see what is the actual, how did this score come about, because it's really about the individual metrics. And I can see all the results here as well. So we try to make sure that all the data is there. So that means currently build number 4 is not deployed in prod, still waiting. So let me double check. Still build number 3 in prod. But if I now say, sure, you go, now Captain continues that workflow. Okay. And as I said, I could either do this through the UI. We also have our friends at Citrix. They developed a chatbot for Captain. So there's also an integration with Slack where you get a Slack notification. Then in Slack, you can click on yes or no. So there's, and obviously you can do this with any type of configuration management software that you have that gives you information about a configuration change that should be approved or a deployment. All right. And now if I go back, what I should see, my process continues now. It was approved. And now the configuration change happens. And then the next thing, what I should see is then the deployment, probably in a minute or two. And then the process continues until it does another validation if everything is really good in prod. So I want to cover this here because this is a really important piece, the quality gate capability that you see here as part of end-to-end delivery. But I first want to give you a little background. So let me first finish these slides here because this kind of just explains exactly what I've shown in the demo. Yeah, use example as well, right? You saw the Captain end-to-end magic now. One of our users, Patrick from Amazon, they are integrating this with their GitLab CI, where they use GitLab for building their containers, and then they're kicking off from GitLab a Captain workflow that is then doing the delivery through multi-stages. But it's all been kicked off when a new container is pushed to a registry, and then they make a call to the Captain API. So just showing you that you can obviously integrate this into existing delivery models. Now, this is important now for me. This is the section now where I talk about too much time is spent in manual deployment validation. This is where I want to go into this SLI, SLO heat map stuff that I showed you. Now, why do I make this claim? I make the claim that a lot of time is wasted in evaluation right now is because this is what I've seen internally and also with people that we work with. So if you have your existing delivery pipeline and then you build, you deploy, and hopefully run some automated tests, then typically there comes a phase of manual approval because somebody then needs to sit down and say, okay, what's our test coverage? Oh, our Selenium tests 2 failed. Is this business critical, yes or no? Then maybe you have integrated performance tests, but then somebody needs to look at the results and say, hey, response time is actually pretty cool. It's pretty fast, but now we have 50% more memory consumption, or we're using twice as many containers to achieve the same throughput. Is this good, yes or no? And then if you also add monitoring to the mix, whether it's Prometheus or Dynatrace, then it's more data that sometimes is not always fully connected with your tests and with your deployment. And so it just takes time to analyze all this data. And therefore, we come up with spending a lot of time in saying up or thumbs up or thumbs down. So our approach is speeding up this analysis using an SLI and SLO based quality gate approach. So what that means, first of all, SLIs, SLOs, hopefully not new for most of you. You have heard it. This comes out of Google's SRE practices. Just a quick recap, what it really is. Google has been basically also not reinventing the wheel, but I think they did a much better job in articulating and coming up with a practice. So Google says we're looking at SLIs, service level indicators. This is something that is measurable, something like an error rate of your login requests. Then you specify SLOs, your objectives, basically what is your success criteria for you to consider a certain metric, a certain SLI to be good. And typically this is also in production done with a binding target. So for instance, login error rate must be less than 2% over a 30-day period. And that's when you consider this as a good metric, a good service indicator. And an SLA, which is most likely known by more people, this is kind of what happens if we are not meeting our SLOs. Maybe there's a legal agreement, maybe you know that you're losing customers or users to your competition, or maybe there's really some binding contract with a third party. So overall, it's a very simple concept. SLIs drive SLOs, which inform SLAs, something that is measurable against an objective, and then the definition of what happens if something is wrong. Great video also from the Google folks, and a lot of great literature out there. Now, why am I talking about this? Because we see more and more folks really, following the Google best practice, defining SLOs in their monitoring tools, and then basically get the key SLOs around typically throughput, failure rate, response time, so performance, and maybe some additional metrics, and get this in the production environment. So organizations really sit down and say, what's the definition of success, and how can we monitor this in production? And we basically say, well, this is great. If you have already defined metrics, SLIs that are important for you in production, why not shift them left and have them analyzed, including maybe some other additional metrics that may not have a negative business impact if they are not good in production, but take those and then add a couple of additional ones and do the same type of analysis in pre-prod. Every time you run a build, every time you have a new commit, every time you run a test, and have a system automatically analyze basically a list of SLIs against your objectives, and then come up with a simple grading mechanism to then say good or no good, so that you can feed it back to your pipeline. Does this make sense? Yeah. Good. So how does Captain implement this? Captain, as everything that Captain does, it's event-driven. That means when Captain is executing the quality gate part of the process, it basically reaches out to tools that can provide input data, like the data sources. It could be, we have an integration with Dynatrace, with Prometheus, with Neoload. You've seen Splunk earlier, maybe. There's people building integrations to pull out Splunk data. We have one organization, they're building an integration with Weaveworks, Wavefront. So you can really put in any type of data source. The way Captain internally works, if you want Captain to then fulfill this process, you need to specify your SLIs. So what metrics do you want? You specify this in a YAML file, like in this case, error rate, count number of database calls, and JVM memory. So it's a logical name on the left, and then on the right, tool-specific query language. This could be PromQL for Prometheus. In this case, this is a Dynatrace query. And then you also have a second file which defines your SLOs. So what type of objectives do you have for every SLI? So for error rate, what's the pass criteria? Or for count number of database calls, pass and warning criteria, where Captain allows you to do two things. You can either specify hard-coded thresholds, like, right, we expect the error range, the error rate to be smaller than 1%, but you can also work with percentage numbers, which means it is comparing it with a baseline from previous runs. So you can also use it for regression detection. And you can also combine it. You can say, my upper limit for this metric is X, let's say 100 millisecond response time, but also I don't want the response time to degrade by more than 5% from my previous baseline builds. And when you then use Captain for the quality gate evaluation, right? You can also use it standalone, as it shows here. You can say Captain start evaluation. Then Captain is basically sending out an event and say, hey, tools, whoever can deliver me these values, these SLIs, please go off and give me the values. They then report back to the event system, through the event architecture, like in this case, 5 database calls, 360 megabyte memory, and so on. Then Captain looks at every metric result, grades it based on your pass and warning criteria, and then comes up with an overall score that we normalize between 0 and 100. And then based on the total score definition, Captain can then say, this is a green build or pass build, this is warning, or this is failed. And this is the metric you saw earlier that either is pulled back to Captain's delivery workflow if you use Captain for end-to-end delivery, or if you are integrating Captain with your existing delivery, this will be the number that will be reported back to, let's say, to your Jenkins. And I've shown you this earlier already a little bit. For Dynatrace, we made this a little easier even. You don't need to write YAMLs. You can write YAMLs. But for Dynatrace users, we just allow them to build a dashboard, put all the metrics, their SLIs on there that they want to have analyzed. And then Captain, every time you say, Captain, please, I don't want to look at the dashboard. You look at the dashboard. Captain looks at the dashboard through the API and then calculates our scoring. Right? So that means if I go back to my demo here, this list here underneath the hood are YAMLs. So behind every line here is a query, and also there's a definition of my objectives, so I can actually show my SLOs. So here are my individual objectives in YAML, right? And you can specify them as YAML. You can give these YAML files to Captain, uploading it to its Git repo, or what I meant, the way I'm doing it, because I'm using Dynatrace, my monitoring tool of choice. I can just build a dashboard and just put whatever metric I want on it, and then I annotate my metrics with pass and warning criteria. So if I zoom in here a little bit, right, you annotate it, and then Captain is just using this information to do the comparison. So it's really simple. Building a dashboard, putting metrics on, define your criteria, and then Captain automates the analysis, which means for every time every time I did an evaluation, it compared it with the previous build, right? So that means when I click, I've specified always to take the latest build as reference. This is why kind of this left column here that's kind of shady is the reference build. So I can see for every build what was the reference build. I also have each individual metric as a raw value. I also have a charting option, so I can see over time how individual metrics have kind of, progressed. It's also great to see trends. Yeah, it's also there. And as I said, I can easily not only integrate this with my full end-to-end delivery model in Captain, but I could, for instance, I have my Jenkins here. I can also kick this off from Jenkins. Right? If you use Jenkins or any other tool for delivery and for running some tests, then you can just make a REST call to Captain, say, please, Captain, you have a certain project, and I want you to then now run your quality gate, and you can give it timestamps, like time ranges. So if I do this now, if I do a build, and you'll see that I have done this also quite a lot in my demos, Jenkins will basically trigger just the quality gate workflow, and what will come back from Captain should be a green, a yellow, or a red, which is then also marking my build. That's great. So it's red. And it seems that Captain's score was 68% only. This is why it was red. I can also go to the results, obviously, to the details. So that means I also get a direct link. And now I get to see, what was this? Just refresh here. I should be able to get the information about what the individual results actually were and why it failed.
Okay. And Andy, do any other tools that collect metrics that can be read into Captain? Can any of those other metrics tools also use the annotations?
Meaning, which annotations do you mean?
So when you put together the Dynatrace dashboard, you took the annotated Dynatrace dashboard, and that built out some of your SLI SLOs. Do other tools that Captain can pull from, as far as can they also use the annotations?
Yes, and the nice thing is, so in general, we have separated the definition of where the data comes from and how to query it from the actual objective. That's the first thing, that it's separated. In the Dynatrace integration, we take a dashboard that contains both information, and then we automatically generate these YAML files basically out of that dashboard definition. And so any other tool can do the same thing. Exactly, yeah. Or you separate it and you say you have one group of people that defines which metrics in a YAML file, and the other group that specifies your objectives. But I like the way we did it here, and any other tool can do the same thing. Yeah. So underneath the hood, really what happened, let me just show you this again, is so Captain has this GitHub repo that I showed you in the beginning. Actually, I don't think I've shown you, but for every for every project, Captain keeps a Git repo, and you can give an upstream Git. Like in my case, I've given it this upstream Git repo. So here is my shipyard file that I've showed you earlier. That's up here, but then also for every single stage for the delivery use case, you get a branch fully automatically. And if I now go to staging, so what I have in staging is all the additional config files that Captain needs or that the individual tools need. So they're organized by service. So I have my simple node service, and in here I have my subfolder for Helm, where my Helm charts are, and these are actually also the Helm charts. But if you look at the timestamp change, the values YAML, this is something that was changed to build number 4 fully automatically by one of the tools that is participating in the Captain workflow when I gave it a new version. What else do I have in here? I have my JMeter scripts that then JMeter can use when it's called to execute a test in staging for a particular service. It can then reach out and gets all these files through the Captain API. I have my SLO file in here, as you can see, right? This is the SLO file with all the criteria. In my case, this SLO file gets automatically generated because my Dynatrace integration is parsing this dashboard, because it knows this dashboard is called KQG, Captain Quality Gate, for this project, for this service, for this stage. So it automatically generates that YAML file. And this is why any other tool can do it. So this is my SLO. And then the SLI is specific to the monitoring tool. This is why you will find the SLI, which is basically the definition of which indicators do I have and what's the query behind the scenes. This is, but if you generate this, or if you let people just do this manually and then upload it, or you let your developers define them, that's up to you in the end.
So how does the so I see the SLIs with the project specific query language. How does Captain know which tool to talk to for that specific metric?
So Captain sends an event, and Captain sends an event and basically says, I need SLIs. And that means, as Captain is an event-driven system, then every tool can basically say, hey, I'm a data source tool, I'm a monitoring tool. Let me see if the user has specified an SLI YAML in my tool-specific subdirectory. So, right, the reason why we have go to staging, the terminology goes like this, or the spec. You have a folder for the service, which in my case was called simple node, and then for every tool you have a subfolder where you put the tool specific things. So if I have Dynatrace and let's say Prometheus as 2 monitoring tools, every tool will receive the event of, hey, please give me, I'm in the phase now of retrieving SLIs. Every tool can then look into, hey, does the user really want me to retrieve SLIs? If so, it does it and then sends it back to Captain. And then Captain, we have one service in Captain. It's called the Lighthouse service. This is kind of the core service for the quality gate. Is then waiting for all the results and is then comparing it with the objectives. And this is also why we allow you to have a nice separation between data retrieval and then data analysis. Does this make sense, Jason?
Yes, definitely.
Right. Cool. All right. I want to get almost done here. Just want to show you that a classical use case, also what people use this for, is integrating this in their existing pipelines. Like Christian, they're using GitLab for build, deploy, test, and then in the verify stage, they simply call the Captain Quality Gate. So this is really great because it really shows the power of, you can really take any use case and just integrate it in your existing pipeline. And so with this, gradually, slowly, kind of automate individual things in your pipeline that are currently manual. Last use case, and I'm just glancing over it, is speeding up troubleshooting in production. So we see a lot of organizations spending a lot of time in manual troubleshooting and remediation. So our approach is again an event-driven approach to remediation. What this means is, just as you can define delivery workflows that I've shown you through the shipyard file, you can define a remediation workflow. And if you have a monitoring tool that, for instance, alerts you on, hey, there's a problem, there's a conversion rate drop, and the root cause is CPU pressure, then Captain you can send this event to Captain, and Captain can then map a problem to a remediation process definition. We call it, it is specified in a so-called remediation YAML file, where you basically say, if a certain problem comes in this case conversion rate drop, then I have certain actions that I want Captain to execute. The first one will be, for this particular problem, scaling up. Now remember, Captain doesn't scale up. What Captain does, it sends an event to say, I need a tool that can do the action scaling, and here is some additional values, and that's the problem context. Could be any type of tool that can receive that event. Now, the next step is I think the important thing is, after the action is executed, Captain then goes back into looking at your SLOs. We also call them BLOs here for business level objectives, because in production you may also want to include things like conversion rate, user experience, so business metrics. But essentially it's the same thing. You can define which metrics, which SLIs should be analyzed after every remediation, and if it's good, great. But if the system is still unhealthy, then Captain would continue with the next action, and then again evaluate, because we want to make sure the system comes back to a healthy state. And at the end of the process, if nothing happened or works, obviously you can still then escalate it. Right? So this is kind of what we want, what we offer for production remediation. We call it closed loop remediation, because it's always a evaluate the situation, execute an action, evaluate, and then execute, evaluate. So that's closed loop. It's always the evaluation. Now, while this sounds great and very appealing, and I think a lot of people want this, a lot of people are also scared of doing this in production fully automatically. And this is why I believe this is why chaos engineering is so great, because we can use chaos engineering and Captain in this case, I think what I would call test-driven operations, which means you can use Captain to execute your performance tests, but also at the same time launch your chaos tests. So run some load and some chaos. First of all, it can help you to validate, does your monitoring work correctly? Do you get the alerts you're expecting when you are executing one of these chaos experiments? And then you can test and refine and define your auto remediation scripts. And you do this in a controlled test environment, basically, right? It's the same process again, but I think this is extremely powerful. This is also why we are partnering and integrating with tools like Litmus, which is another CNCF project, where we're working very closely with Gremlin as well. But I believe this allows us to, because this is also production code in the end, and no code in production should get into production untested. And that also includes, obviously, the code for remediation, whether this is the process definition on the left or the individual actions like stop traffic and restart process, they all need to be tested. Okay. So to wrap it up, hopefully everybody understands, or at least you get a little better idea on what Captain is. You can pick different use cases, you bring your configuration, you connect your tools, and then Captain automates the configuration, and it gives you basically these use cases as a self-service. With self-service, we mean you can trigger it through an API, you can do it through the CLI. It's very easy to use, and everything is event-driven. And it's basically, in the end, it's an event-driven process orchestration engine based on standards. And we really hope to help organizations with this to really solve the challenges that were also highlighted in the State of DevOps report. And yeah, hopefully with this we can make our contribution. And if you want to get started, a good way to start is the tutorials and a very lightweight installation. I know, Jason, you're working for Rancher. There's a K3S tutorial out there that we have. But feel free to install Kapton anywhere where you want and use it for the different tutorials and use cases and get familiar with it and provide us feedback. So what would be really great that we get feedback. Join us on the Slack channel, slack.kapton.sh, star us on GitHub, follow us on Twitter. Would be great to grow the community. Thank you.
Wow, Andy, that's really great. I was not aware of this tool, but that's something I think I'm going to start playing with. I like that a lot. Okay. So before we close out for anybody have questions for Andy as far as Kapton goes? All right.
Also, feel free to unmute if you want to. Or, I guess.
All right. So with that, I'll close up. So as far as closing business goes, if you'd like to get in touch with Andy, he has his contact information there. I am making a recording of this. I'll do some light editing to chop some things out. Once that link that's available, I'll link that on the on this specific event on the meetup page. December's meetup is already up. It'll be December 15th. We already have at least one presenter already booked. I haven't updated the event yet. I'm still waiting to hear yes or no from a second presenter. But the information will be up probably later this week, early next week. So just know we'll have December 15th, and then we'll be scheduling January not very long after. So with that, if there's nothing else, you all have a wonderful evening. And Andy, thanks for waking up and staying late with us.
Yeah. Good night. Bye-bye.
Good night all.